In the previous video, we looked at the practices involved in software project management, right? So what all are the important tasks that a software project manager does, such as forming and managing the development team, project scheduling, project estimation, risk management, and so on. So in this video, we'll be talking about project estimation techniques. So before we look at the actual techniques used for estimation, let's reflect on why it is important to do project estimation. So one is to establish the cost of the project, right? So I need to know how much money is required to build the software, and this information has to be communicated to the clients. Second, I also need to establish a schedule for the project, right? I need to know when the project is likely to get completed. And as the project is moving along, is it on schedule? Is it behind schedule? How many people are required? All these depend on the estimates of the project. Also, from the client's perspective, when they bid for software projects, these cost and schedule estimates must be provided to the clients for the development contract. And of course, it is not possible to accurately establish or estimate the exact cost and the schedule. And these estimates, it depends on the level of information available about the project. So the more detailed information we have about the project, the more accurate the estimation can be. So now let's reflect on this question on what all can be estimated in a project, right? So let's say you are running a company and you are bidding for software projects. So what are the key parameters that you will provide an estimate for? So what are the key parameters that are required to do project estimation? You can pause this video and think about some parameters before proceeding. So let's look at some key estimation parameters, right? So some of you might have thought about the size of the code, that is the number of lines of code. Yes, this is important to estimate the number of lines of code, and the number of lines of code is usually represented as klog, which is number of 1000 lines of code. So 1 klog is 1000 lines of code. So this is one estimation parameter. But if you think about it, the size of the code alone cannot be provided to the clients, right? Especially to justify the cost. So another key estimation parameter is effort, right? And this is also an important parameter. And based on this, we can determine how many people are required to form the team, right? And in the software industry, effort is usually measured in terms of person month. So 1 person month is the effort an individual can typically put in a month. So let's take an example. Let's say a project, it requires 12 person months of development time. Right, so let's assume that we have estimated this quantity. We will see how we can do this estimation, but let's say we have got an estimate that this project requires 12 person months of development time. So what that means is, if there are 12 people, then this project, and if all these 12 people work on this project for 1 month, then this project can get completed, right? So if we have only 4 developers, that means this project will require 3 months. And if we have just 2 developers, then it will require 6 months. So you might think it is better to think in terms of, total hours. How much hours does the entire project take? But work is often expressed in person month units because it is easier to get a feel for how many people might be needed to finish the development work in a fixed time. So now that we have looked at some key estimation parameters, let's look at project estimation techniques. So one broad estimation technique is empirical estimation, right? And what this means is we ask experts, we ask people who have completed similar projects in the past, and they provide estimates for us for this new project. Another type of estimation technique is using heuristics, right? And what this means is relationships that exist between different parameters, like we saw effort, time. These can be modeled using suitable mathematical expressions. So we'll be looking at heuristic techniques also in this video. So now let us look at some empirical estimation techniques. Right? One popular empirical estimation technique is to use expert's judgment, right? So an expert, he or she makes an educated guess about the problem size after analyzing the problem thoroughly, right? They estimate the cost of different components in the system, and then they combine all these estimates for the individual modules to arrive at the overall estimate. So now that we have seen what expert judgment is, what do you think are drawbacks of this method? What are the drawbacks of asking an expert to give the estimates for the project? You can pause this video and think about some drawbacks before proceeding. Okay, so now let's look at some drawbacks of expert judgment, right? So one is these experts are humans and hence they can make errors. They can have some individual biases towards a particular technology or a particular framework. And hence, because of this, they might give some optimistic estimates based on their expertise. And also maybe if they want the contract to be won, then they might give even more optimistic estimates. Another drawback is that they might overlook some factors, right? They might not have adequate knowledge in particular areas. So for example, they might be very knowledgeable in the database and the user interface part, but they might lack knowledge about maybe additional modules or additional plugins. And because of this, they cannot accurately provide an estimation. So, but do you think this can be solved by a group of experts? So, yes, maybe to an extent, but still the entire group can also be biased, right? And the decision made by the group, it may be dominated by some members who are overly assertive or maybe some senior members. So they might influence the decision of the entire group. So to overcome the drawbacks of expert judgment, the Delphi technique can be used. So what is the Delphi technique? So in this technique, we have a group of experts and we have a coordinator. So the coordinator provides each expert with a copy of the SRS, the requirements, and a form for recording the cost estimates. So the experts go through the requirements, the SRS, the different modules, and then they provide their estimates and they submit their estimates to the coordinator. Note that each of these experts are submitting it individually. They are not discussing with each other. And what the coordinator does is the coordinator prepares a summary and distributes it to all the estimators, to the experts. Now the experts look at this summary, and based on this, they re-estimate based on all the comments from all the experts. And note that these comments are still anonymous. Experts do not know who has provided the estimation. And this process is iterated over several rounds. And the coordinator compiles the results and prepares the final estimate. So as we saw, there's no discussion between the experts is allowed during the entire estimation process, because some experts or some people can get influenced by an experienced or a senior estimator. And after several rounds of iterations, the coordinator takes responsibility of compiling all the results and prepares the final estimate. Now, the next important type of project estimation techniques is known as heuristic techniques. So, in heuristic techniques, we provide estimations by doing some modeling using some suitable mathematical expressions. So a popular model which has been used to estimate effort is known as the constructive cost estimation model, or the COCOMO model. This model was proposed by Boehm in 1981. And the formula which is used to estimate effort is nothing but A multiplied by size raised to B, where size is the size of the project in kilo lines of code. And what is this A and B, right? So the values of A and B, it depends on the type of project or the type of software you're building. So Boehm, he classified projects as one, organic. So an organic project involves building a very well understood application program, and the size of the team is also small, and most of them are experienced. Another type of project can be a semi-detached project, which has a mix of both experienced and inexperienced people, and they might have some limited experience building related systems. And the third type of project is an embedded project, where the project is strongly coupled with hardware, and the team size also might be large, and there might be many inexperienced people. So based on the type of project, there we assign different values for A and B. And what you have seen is that the effort, it not only depends on the size of the project, but also the type of project, the composition of the team is also an important factor in which the estimate depends on. So based on an empirical analysis of several projects, Boehm came up with these values for A and B for each of the types of projects. So you can see that the values of the constants of A and B, they are based on the type of project, right? And for organic projects, the values are the least. It's 2.4 and 1.05, and it is highest for embedded projects. And this makes sense because embedded projects, as we saw, it involves coupling with hardware, the team is large, there might be many inexperienced people, and because of this, the effort increases exponentially as the complexity of the project and the team increases. So based on these constants, the initial estimate or the nominal estimate is calculated in terms of the effort. Now let's take the example of the Amazon seller portal and try to come up with the initial estimated effort to build such a system. Right? The first thing which we need to identify is what type of system is this Amazon seller portal, right? So according to me, this is not a straightforward software system. There are several modules which have to interface with the main Amazon system, with the banks for payment, etc. So I would maybe classify it as a semi-detached system. In some cases, it can also be an embedded system, right? So now that we have identified what type of system it is, now let us try to, second thing to do is to estimate the number of lines of code. So recall that we had identified some requirements in the previous weeks. So we have adding, editing, deleting catalog, the inventory, tracking orders, payments, sales, customer feedback. So all of these things are there. And for each of these modules, I estimate the number of lines of code required. So how does one do it, right? So this itself is a very difficult task. And usually the project manager looks at data from previous projects to come up with these estimates. So for example, in a previous project, there would have been a module which captured customer feedback. And based on that, the software manager makes estimates for that module. So I add up all the lines of codes for all the module and I get the total of 4,000 lines of code, which is nothing but 4 kilo lines of code. So now let's look at the estimations which we have till now. We know that the system is semi-detached. We have the size in kilo lines of code. We plug these values in and we get the effort is roughly around 16 person months or 15.83 person months. So what does this mean? This is our initial estimate, right? So we require around 15.83 person months. That is around 16 people working full time can finish this project in 1 month. And based on this, we can estimate the cost, right? So let's say that the average salary of the 16 people is 75,000 per month. So then the total cost comes up to around 12 lakhs. So now, apart from the size of the code, we need to consider other factors also to estimate the effort required for a project, right? So let's reflect on this. So what are the other factors which have to be considered to estimate the effort required for a project? You can pause this video and think about some other factors before proceeding. Okay, so apart from the size of the project, so what other factors have to be considered? Let's look at that. So some of you might have said about the people working in the project, right? Some team members may be experienced, but not in the programming framework required for this project. Others may not have domain experience. So in this case, in the case of the Amazon seller portal, how an e-commerce application works, and hence some time will go in learning about the domain. So another factor can be the technical attributes or the finer details about the product. So is the database large? Is it complex? How complicated is the entire product? So is reliability an important part of the system? So these factors also have to be considered when we estimate the effort. And estimation also depends on the tools and practices which are used by the team, right? How if the practices and tools are not very effective, then maybe more effort is required for the project. So in the COCOMO model, after determining this initial estimate, some other factors are added in order to obtain the final estimate. And these factors are known as cost drivers, right? So this table shows 15 such cost drivers, and these attributes like the product, computer attributes, personal attributes, these are similar to what we discussed earlier, right? Like software reliability. So if the reliability required is very high, then we have a higher cost driver compared to when it is very low, right? So let's look at our example. So let's say we want to estimate the effort for the Amazon seller portal. Let's look at some of these attributes. So for example, we want the system to be highly reliable because orders and money are involved, right? So we will choose a cost driver which is very high for reliability. And maybe my database size, it is also quite large. So I will choose a cost driver which is high. Now, if we look at some personnel attributes, let's say my application experience of my team is low, right? So I will choose this as 1.13, which is higher than if it is very high. And let's say my team has good programming language experience, so I rate it as high, right? So the multiplying factor for all 15 cost drivers, they are multiplied to get the effort adjustment factor, right? So in this case, I'm just taking 4 drivers for simplicity. So let's recall that our initial estimate was 15.83 person month. Now I take these cost drivers, multiply all of them together, and this gives me the effort adjustment factor, which is 1.62. And now my final estimate is calculated by multiplying the initial estimate with this effort adjustment factor. And so I get an final estimate of 25.65 person months. So to summarize the COCOMO model, first we determine the type of product which has to be built. Then we estimate the number of lines of code for each module. And based on the formula, we get the initial estimate. And from this initial estimate, we calculate the effort adjustment factor by considering the 15 cost drivers. And then we multiply the initial estimate with these adjustment factors to get the overall estimate. So if you have noticed, one important thing to note is that the overall estimate, it depends on the estimation of the lines of code for each module, right? And so it is important to get as much detail about the software, and we should also be aware of our biases when estimating the size of various components. So to summarize, in this video, we looked at several estimation techniques, both empirical and heuristic. And another question now to ask is which technique to use, right, for a particular project. So what estimation techniques project managers use, it depends on various factors like the type of organization, the type of product which is being built, right? And it depends on the practices in your organization as well. So for example, the British Computer Society survey of more than 1,000 projects found that 92% of the project managers, they made their estimates using experience instead of formulas. So now that we have learned these estimation techniques, you will encounter these or maybe some variations of these as you start working in the software industry.